Hi everybody, welcome to this live stream of At the Eyepiece. I must say I'm doing a little bit of testing here. I'm not sure how well this is going to come through. I am having an odd issue with my microphone tonight, but hopefully you can hear me okay. Now it is very warm, so I do have the AC running. I am in my observatory, and yes, this is a live view of Jupiter. Now I do have some passing clouds from time to time, so the image is going to get bright and the image is going to fade out from time to time. But of course, what you are seeing right now is a live image of Jupiter. I'm imaging with a Celestron C8. Right now I'm not using a Barlow lens to magnify the image. This is straight up just directly to the camera. The camera, as you can see here from the properties on the window, is DMK21. This is a very old camera, really, but it has suited me just fine, done a great job for me as I have used it for quite a few years now. And let's see if we can zoom in just a bit here to our Jupiter image. I will center it up here a little bit for you. Okay, so we are using, also, to make a note here, we are using a monochrome imager. Camera's black and white, basically. So you're not going to see color in Jupiter tonight, but I will point out some of the main features that you're seeing. Now just keep this in mind. You're seeing another planet, and the bands that you're seeing, the two almost vertical lines there, are the cloud belts. Jupiter has two main cloud belts, the north equatorial belt and the south equatorial belt. It actually has many other belts and zones that you can see and that you can follow along with your own telescope. In fact, you don't even need a very large telescope to enjoy Jupiter. As a matter of fact, if you just take a pair of binoculars out, you can see Jupiter's clearly not a star when you look at it. And right now it's just about directly south of wherever you might be. And I would say probably a good 30 or so degrees above the horizon. That bright star is actually Jupiter. It's just to the lower left now of the moon, probably, let's see, maybe if you hold your fist out, just about that distance from the moon to the lower left. That is indeed Jupiter. Now, if you have a pair of binoculars, take them out, take a look. If you see stars next to Jupiter, well, those aren't stars at all. Those are Jupiter's moons. That's right, you can go ahead with a pair of binoculars and see our moon, which is, our closest celestial neighbor, and then scoot down to the lower left and see Jupiter's and its moons. Now, it has lots of moons, but these four are called the Galilean moons, and they are Io, Europa, Ganymede, and Callisto. And the cool thing with Jupiter, I mean, there is really so many cool things with Jupiter, but as far as the moons go, sometimes you will be able to go ahead and watch a moon shadow transit in front of Jupiter. It'll be as if there's an inky black dot traversing the disk of Jupiter. And sometimes, if you're really lucky, you'll get what is called a double shadow transit. And then if you're really, really lucky, you'll actually get a triple transit. That's right, triple transits actually exist. I've got to see one. Now, right now, we have Io. You can't probably see it, but I might try to highlight what I think in this image is actually Io. And I'm going to say Io is right about here. The actual moon itself is somewhere thereabouts. I think that dark little spot there might be Io, maybe not. But either way, the other interesting object that we're seeing tonight is this right here. Very clear, that is the Great Red Spot. That is a storm that has been going on Jupiter for hundreds and hundreds and hundreds of years. probably, well, at least hopefully, it's going to be raging for a while. They actually say it's getting smaller and smaller over the centuries, so it's an interesting phenomenon. But anyway, back to all these cloud belts and zones and things. The South Equatorial Belt, the North Equatorial Belt, you have bunches of other belts and what's called zones in between of the belts that are just full of detail. That is why Jupiter is probably my favorite planet. I know Saturn's great, Saturn's wonderful, Saturn's fantastic, it's gorgeous, it's beautiful. But as far as things that are going on, well, Jupiter's number one in my book for that. Because just like we're seeing tonight, we got the Great Red Spot Transit, and hopefully we'll be able to see a shadow transit here with this type of magnification and with this setup tonight. Again, I do apologize for the ambient noise. I'm running the AC. It's pretty right next to me. I'm out in the observatory right now, and I'm not sure. I have a nice little microphone here, but it's not being recognized for some reason this evening by the computer, so I'm having to use the built-in computer on the Mac, and I'm just not sure how well it's picking up my voice. Hopefully, it's being picked up fairly well. Now, don't worry, we are actually going to be seeing a couple of different objects tonight. We're going to be looking at Jupiter here for a while, then we're going to switch gears and we're moving on over to the moon. Let me go ahead and I'm going to show you another portion of my screen. Give me one moment here. I'm going to add another window. Here we go. Window capture. Okay, and as you are hopefully seeing here up on your screen, this is a planetarium program called Sky Safari, and I'm going to zoom on out here so that we can get an idea of where you can go ahead outside and check out Jupiter for yourself. So if we are looking to the south, this green line is what's called the meridian. This is an imaginary line that basically divides the sky in half, if you will. And of course, we got the moon up here on the upper right-hand area here. And then, of course, we have Jupiter. It's pretty much the brightest object in that region of the sky right now. Now, as we zoom in here, you will begin to see some of the moons that we were talking about. And right now, you can see three. If you were outside, pair of binoculars, or nifty little refracting telescope. You know, maybe you've got something from Explore Scientific, like a 4-inch or 80mm refractor. You can take that outside and look that up. These are great planetary instruments. If not, take a pair of binoculars, whatever instrument you got. You're going to go out there and you're going to see three planets. You're going to see, or I'm sorry, three moons. You're going to see two off to the left of Jupiter and one off to the right. The two off to the left are Ganymede and Europa. And the one off to the right is Callisto. Now, if we get a little bit zoomed in further here, you will actually see where Io is as far as its position on Jupiter right now. And we have some passing clouds that are interfering a bit with the view. But let me see if I can tweak here just a little bit so we can get a little bit of detail maybe. That's about as much as we're going to be able to do. You can kind of see here as we go back to the view of our telescope right here. You can see how that position of the Great Red Spot, which is this dark darker region. If you were looking at this through a telescope, it would probably be more of a light cream, orange kind of cream color, I would say. It's not really red, but it's just what they describe it as. So that is the great red spot. Okay, right there. And actually, that's interesting that that's not coming through. I don't think. It doesn't look like that is actually coming through to your screen. So I'm not sure if there's going to be any way to do that so where you can see what I'm actually highlighting here. I'm highlighting it on my screen with the program, but I'm not sure if you're getting it on yours. That's kind of a bummer. But I think you'll be able to make it out there if you can here. Just getting some things out from the feeds. Hopefully that's going to come through okay. Let's go back to our instrument here. Just brighten that up a bit. Just not going to be able to do it too much. Now you will notice Jupiter's jumping all over the place. That's what we call seeing. Okay, it's the amount, it's how turbulent the air is where you are observing from. That's why professional observatories generally like to get very high up on mountaintops, like on Mauna Kea up in Hawaii, or down in Chile, and some of those high mountains. They want to get above as much as the atmosphere as possible. I mean, that's why they put Hubble in space, so that Hubble would get above, well, all the atmosphere and have the clearest possible view without all of this shakiness going on. Sometimes it can be very steady, and most of the time where I'm actually broadcasting from, which is the Middle Tennessee area, this is quite common. In fact, it's actually not too bad, to be completely honest with you, with how much it's shaking. But the shaking is kind of bad. It's not what we want. We want a nice, steady view as much as possible so that we can tease out these details, because there are just so many things to see when you're observing Jupiter. As we were talking about, great red spot. These cloud bands always have things going on. Festoons, white ovals, little storms, just all kinds of phenomenon going on. And let's see if we have, I'm going to back out. I'm going to show you again the window for the Sky Safari app, just so that you can get an idea of what some of these features may look like. Now, believe it or not, if you had a telescope, you could be seeing a view very similar to what you're seeing here. Very similar. I mean, obviously this is probably done with a professional observatory and lots of processing for the photo, but it's still very fun to go out there and tease out some of the details. You can see these darker features in the equatorial zone here, which is basically that white zone right in the middle through the planet dissecting Jupiter there between the north equatorial belt and the south equatorial belt. Those are the festoons that I was talking about. Those are features that generally dip from a belt into a zone. And they are always fun to go ahead and tease out those details. You can see some of the white ovals as well. Those are more closer to the north temperate zone and the north polar region there of Jupiter. Also down in the south temperate belt in Jupiter as well. Let's zoom out here a little bit. I'll show you there. There's the Ganymede and Europa and Callisto. So there's all three views of the Galilean moons right now on Jupiter. Now I could go ahead and increase my exposure here a little bit, and I could show you. I don't have the field of view on this camera that would permit me to bring in all the other moons, but that, let me switch back to this so you can actually see what I'm showing. I guess that would help. There we are. So I've increased my exposure so that we can pull in Europa. That's actually the moon Europa there for Jupiter. So if we roll back our exposure just a bit, you can see the moon is slowly flickering out of the view there because Jupiter is just so overwhelmingly bright. We can leave it right about there. Turn off that air conditioning unit. Maybe that'll help keep the ambient noise down. You can hear me clear as I describe some of the other things that we're going to be looking at tonight. Now, as far as equipment goes, I am using a Celestron C8. It's an 8-inch aperture telescope. And I'm using a computerized mount. That is what is permitting me to track Jupiter and keep it in the field of view this whole time. And as far as the camera goes, on the screen here is actually the camera software window that you're viewing. It is an older model camera. It's a DMK21. It's a monochrome or black and white. So you're not going to see these colors that I might have been calling out earlier, meaning the reddish or the light orange or cream color to the great red spot. You're just going to see this in a monochromatic. We actually prefer mono a lot of times as amateur astronomers because the mono camera is a little bit more sensitive than your color cameras. It has to deal with what's called, on color, being the Batrix, I believe it's the Batrix matrix, if I'm not mistaken. And that reduces some of the resolution and the capabilities of those cameras a bit. But I do realize color is what really nabs people's attention. Maybe one day we'll be broadcasting in a color camera here, but for now, this is going to do. We are still seeing another planet, largest planet, as a matter of fact, in our solar system, Jupiter. We're going to scoot over to the moon here in a little while as well. We're going to keep it on Jupiter just for a bit more. This is live. You are indeed witnessing another planet. You're seeing clouds on another planet. You're seeing the moons orbiting another planet. There's that moon. There's, I believe that was Europa, bringing the exposure up a little bit here so that you can see it. basically right on the planet. Well, not on the planet, but in line of sight to the planet. Somewhere on there is Io. Io is transiting Jupiter right now, and we might be able to see the shadow transit here sometime tonight. Now, the mid transit, as far as the documentation goes here, meaning the shadow should meet the midpoint, is about 10:24 Central Time to me. So that's coming up. I just have not seen any of the shadow yet myself. Sometimes these are difficult to pick up. Sometimes they're easier. But that's the great thing about astronomy is you never know. Seeing can be great, and you'll be able to pick up every single detail possible. Other nights, they're going to be average. You might not be able to see things as clear as you would on other evenings, but there's always something going on. See if I can tweak this a little bit here. Actually going to get a video too of this. And as amateur astronomers, well, even professional, we like to get a video feed of the planet because then we can go ahead and do something called stacking and aligning. And basically, this will, in essence, get rid of all this shakiness. And it uses software and certain algorithms to really bring out the detail in your images. So I'm going to grab some video of this now so that later on I can go ahead and process this and get a really sharper image of Jupiter from all of these processed frames. So right now it's about, I'm almost at 1200 frames captured right now just from this streaming video. And then we'll be able to stack all these later on, get a nice sharp picture of Jupiter. I'm going to stop it at about 1600 frames. Okay. Once again, I'm going to switch back to our Sky Safari app. You can get kind of an idea of what you're looking at here. This is, of course, a much more detailed, kind of exaggerated image. But you can clearly see where you're picking up the Great Red Spot. Also, there seems to be some nice activity there in the north equatorial belt. That's the belt just to the right there of the south equatorial belt where the Great Red Spot's in. And there seems to be some interesting detail going on in that belt itself, meaning some disruptions there. It's the darker features that you kind of see, kind of a elongated, almost curved feature. Probably a festoon. Let's go back to our Jupiter image. There we go. Now I don't want to zoom in. I'm already zoomed in quite a bit actually. That's our 100% normal view, if you will. And I think we were at about 150 there just to make it maybe a little bit easier to see for you on screen there on the channel. Hopefully that's coming through pretty good. Jupiter from our planetarium program. And there's our real Jupiter. Right there, up on the screen. Enjoy the view for a bit. I'm going to step away just to get something to wet my whistle for a moment. Enjoy. I'll be right back. see how that's coming through. I just got this microphone working. This is a lavalier microphone, so it's a little bit closer. I think that's going to be better for the broadcast. I sure hope it is. Oh, hey there, Evan. How you doing? Welcome. Decided to do a YouTube stream tonight. How's this audio coming through? Is it coming through okay? Not sure if you got even audio on your side, but hopefully you do. Okay, now I'm going to switch back here to... This is our live view of Jupiter. Let's switch back to Sky Safari because I want to show you what's going on. Okay, now look there on the far left. That is the shadow transit that we're trying to see if we can capture here live right now. We're trying to see if we can see that inky black dot. The seeing conditions may just be so bad though that we might not be able to see it at this magnification and with the clarity that we're getting for the broadcast. But hey, we'll continue to give it a try here and we'll see what we have. But that is a shadow of Io going across the surface of Jupiter. I mean, how cool is that? That blows my mind. Jupiter got me hooked onto astronomy, so I sure hope it gets you hooked onto astronomy as well. I guess I could go ahead and let me do that. Give me one moment. I'm going to open up another window here. All right, so let's get back to our actual live Jupiter screen. There's our actual live Jupiter. You know, if you look really close, I believe we are beginning to see the dot for Io. And I realize that it might be difficult to see. But let me see if I can point this out to you where I'm thinking it is. And it's right there. Now, of course, you know, it's not going to be... You know, it's not going to pop out like a picture, but I'm pretty sure that might be it indeed. So you go ahead, you tell me, anybody that's watching, why don't you leave it in the comments or the chat window now. Let's flip back to Sky Safari. So there's the general position of Io. You see it there on the left. And let's go back to our live feed. I realize this is a little bit oriented different, but I don't think I can get it to be completely matched up just from the orientation of the camera. All right, so I'm going to bring this up on another computer just to see how my audio is coming through. All right, good. So audio is coming through pretty good. All right, very good. Okay, let's center Jupiter up a little bit better here. We're going to stick on Jupiter just for a little bit, and then we are going to go ahead over to the moon. As the streaming name says, it's going to be Moon and Jupiter, so we will come back to Jupiter here in a moment. But why don't we just go ahead right on over and check out the moon and see how that's doing. Give me one moment, and we will slew to the moon. It is actually pretty close to Jupiter. Okay, and away we go. We're going over to the moon, and there it is. Just a hop, skip, and a jump from Jupiter. Currently in the night sky right now. And let's make our adjustments here to our screen. And let's go ahead and see what we can get to the Terminator. There we go. That's an interesting crater there. Let's brighten up this view a bit. A little bit too much. And let's maybe increase that a little bit more. There we go. I think that's a little bit better. Okay, so there we go. We are on the moon now. And let me bring in another app. This, by the way, is an excellent lunar map or atlas. And it's best thing about it, it's free. It's called Virtual Moon Atlas. You can download it. Just do a Google search, and after a while, it's quite large, but after a while you'll go ahead and you have it, and it's just an excellent atlas. I mean, it's free. You can help you identify the different craters and features that we have on the moon. So right now, I'm going to center up basically where we're at, and this seems to be oriented perfectly actually with the camera. And we are looking at the crater Copernicus, and on the lower left there, with that very interesting little center feature, is Eratosthenes, it looks like. I'm probably slaying the pronunciation of those words, but forgive me. Eratosthenes. Maybe that's how you say that one. Copernicus, much easier. We'll stick with that. So look at the orientation there on the screen. This is the Virtual Moon Atlas that we're seeing. And then let's flip right back to our live video, our live grab. And there we are. And you can see how that lines up perfectly. Copernicus, very interesting crater. That's the one in the upper left-hand not quite the upper left-hand corner there. That's Reinhold. But Copernicus is the main crater there. And then over to the lower right is the Eratosthenes. Saying that right? With, again, look at the interesting features in the actual crater itself, the central raised region in the crater. It almost looks triangular in this perspective. And then, of course, if you look at Copernicus with its terraced crater walls, that's always interesting to see. The shadow there is always cool to see and pick up those extra features there, because it actually kind of it highlights the topography of that crater rim as well on the top there, because of the way the shadows are forming there in the center of the crater, and plus it's got some raised features in its center area as well. So what I can probably do actually is, I wonder if my highlight will bring it up here. Bring this down a little bit. Here we go. So I don't know if this is coming through to you or not on the channel. Let me see. No, it's not. Well, that's unfortunate. I have a program here that can draw on my screen, but it doesn't seem like it's being captured by the open broadcasting software. So we'll just leave it as is. I have a program here that can draw on my screen, but it doesn't seem like it's being captured. Let's mute myself. All right, we will go back to looking at our virtual Moon Atlas program. Get your bearings. This is actually, and I did remember that I oriented the program, this particular program, to be almost exactly with my angle for the camera lens on the particular scope. So you can see how we're lined up pretty well. Now, if we zoom out, we'll show you about where we are looking. I'm going to highlight Copernicus here. Oh, maybe. Seems to be dragging. Turn the air back on now that I have this lavalier microphone. Oops, it's going to be picked up. Yeah, there we go. Okay, so you can see how I have highlighted, finally picked up there, highlighted Copernicus. So what are some cool facts about Copernicus? Well, we've got that there on the right. Height is 11,400 feet. And it's about a 56-mile wide crater. The other main crater that is actually in our live telescopic view right now, and we'll switch back to that right here, that is, let me bring that up here, let me highlight that one. That's kind of a cool one because I like the centralized feature in there. Just right in the center of that crater is almost a triangular shape to me. Hopefully that's coming through to the stream pretty well for you as well. Of course, you gotta be on the window that I'm seeing. Let me go back to that. There we go. Now you can see what I'm talking about. So again, we're seeing a pretty magnified view of the moon with a decent sized aperture telescope. I'm using a Celestron C8 on an Ioptron Go-To mount. This is the reason why we are able to track the moon. However, I want to encourage everyone out there that might be seeing this, and maybe you're seeing the moon for the first time. I want to encourage you to go out there even with a pair of binoculars, because some of the lunar features you can see very clearly even with a pair of binoculars. Now, of course, if you step up to a telescope, it doesn't have to be something, like we're using here. You will be blown away by views that you're able to get through, say, a 4-inch refractor, or maybe even like a 6-inch Newtonian telescope, one like I've had. You can see things just like we're viewing here. You don't need the fancy equipment. I use this because I want to share the view with the world, basically. I want to encourage it that way. I don't get out as much as I should and do the actual person-to-person outreach, but I am going to try to do more of that as well. Used to have a coffee shop here that we actually did that, and I did it actually once a month, and it was great. But that coffee shop closed down. I was so bummed out about that. It was just in a perfect spot, perfect southern, view for the stars, planets, etc. Yeah, we were right next to a parking lot, so you weren't going to see any deep sky objects. But for views like this, the moon, planets, it's perfect. I am just adjusting focus a little bit, see if we can get a little bit tweaked here, but it looks like we were actually pretty good. I probably should have left well enough alone. There we are, we're kind of back there. As you can see, it's shimmering, similar to Jupiter. This probably actually is maybe a little bit more apparent with the shimmering. This is what we call seeing in astronomy talk, and it's basically how the atmosphere above us shakes and messes up the image. Kind of keeps things from being as clear as possible. Let me adjust this down. But overall, we're still able to pick up a lot of cool things. There we go. So let's try to identify where we're at now. So we've got a mountain range there off to the left. I believe they call that Eyepiece. And the crater that you're seeing almost at the very top here, let me see if I can scoot this down a bit. There we go. Okay. So we'll start with the big crater there to the left. I'll warn you, I am probably going to pulverize these pronunciations. But, hey, you can look them up. You'll get the gist. Archimedes there is the neat little crater there to the left, the larger of the main three that we have on screen. I want to call your attention from the other two craters that we saw earlier, especially Copernicus. You remember in the center of those craters, they had a raised formation. We could clearly see that. We could clearly see some other features on the crater floor itself. Notice Archimedes. It's pretty smooth, isn't it? That's because it's filled up with lava a long, long time ago. And it filled up with lava after what is, I believe they called the heavy bombardment period, where most of these craters were probably formed. And we know that this one filled in with lava, and it was probably after the late bombardment, because there's not a whole lot of craterlets in there as well. It's a pretty smooth looking floor. Now, Autolycus is the crater there to the 5 o'clock position of Archimedes, and Aristillus is the final crater there. That third one has a little bit of rays coming off of it there. And again, you can kind of see how that has some terraced features on the crater walls. And it too looks like it does have a central peak to that formation as well. So let's go back over to our program, Virtual Moon Atlas, and show you about where we're centered at. So here was Archimedes. Okay, we'll highlight their name in red there. Autolycus was next. We'll highlight that one. There's Autolycus. And Aristillus is right there. There we are. That mountainous range there below it, that was Alpenius. And I think we'll go up to another crater here. This one I think you can actually see with binoculars. Let's zoom out actually from our moon just to get a better idea about where we're looking. So here's a full screen kind of image of the moon. And right now there's Aristillus that we have highlighted here. So we're looking in the upper portion there of the lunar surface. If this is oriented correctly anyway. Not exactly sure the orientation of this particular program at the moment, meaning it could be flipped upside down. But let's go back to our live view, and there's our live view. Oh, now there's an interesting feature. Let's go ahead and check out what that line is there. That is a valley. And actually we're going to be able to get both of the objects that I wanted to get into. Look at that crater. That one's one that you're probably able to see with a pair of 7x50, maybe 10x50 binoculars. That is Plato. Again, look at how smooth that interior is. Not a whole lot of craterlets, smaller craters from impacts in that one either. So these, right below the main crater that you're seeing here, Plato, right below that you'll see some mountains there. Those are the Alps. And right in there, I believe that is the Valley of the Alps. That kind of line feature that you are picking up here. And I'm going to switch back to our app. Maybe that'll give you a little bit better understanding, having these things labeled. So let me center this back up. So obviously the main big old crater there is Plato. Isn't that beautiful? That is gorgeous. And then you have the mountainous regions, and then that straight line, that line is at an angle maybe from about the 11 o'clock position down to, say, the 5 o'clock position. Okay? So let's go to our virtual moon atlas so I can show you what I'm seeing here. So there's our Plato. It's our main crater here. It's going to take a moment to refresh. There we go. Okay. That crater is 61 miles in diameter. There's our, where is it? Right there. If I can click on it. There we go. Valles Alps. That's 7 miles wide by about 79 miles long. So you can see you don't even need a fancy telescope to enjoy astronomy. I mean, there are so many cool things to see just on the moon. And again, you don't need a big telescope. You can enjoy these views with a modest, high quality aperture, telescope. 80 millimeter, 102 millimeter, something like that. You can spend a lot of enjoyable hours enjoying that. Let me get back to the channel here. Okay, there's no new messages in the chat, but we do have 3 watchers. We do have 3 people watching, so thanks for jumping on in and watching at the Eyepiece Live. If you like things like this, please feel free to subscribe. Don't forget that. We periodically have these live streaming videos posted up. We can have, of course, our podcast streamed to the YouTube channel as well. And of course, from time to time, we'll be doing reviews of astronomical equipment and just sharing other things astronomical. All right, so let's go back to our live view here. There we are. Oops, that's not good. Just had a little error message pop up, but it went away. So I'm not going to worry about it too much. All right, let's go cruising around on the moon and see what other interesting features we can spot. So we like to go along this dark area here called the Terminator. This is where most of the features, look at that Copernicus, that is just gorgeous. This is where some of the more interesting features can be because of the way the shadows affect the views, the highlights, the crater walls, etc. I mean, this area here that we are approaching is obviously very rich in craters. Let's drop this thing. Let's increase gamma a bit. Let's see if we can just dim it down a little bit more. Okay, so let's see whereabouts we are at. I think we are looking at, believe it or not, I think we're looking at Tycho, which is the crater here with the centralized peak. Now, usually during full moon, I believe Tycho is the crater that has just fantastic white bands coming from it, called rays, lunar rays. If I'm not mistaken, Tycho is that feature. But again, that's prominently visible only during, or close to probably full moon. So just kind of keep that in mind while we are at this particular phase of the moon. We're able to, see more features from the perspective of the craters and the way the shadows highlight those features. Leave it on that for a moment. So just so that we have a frame of reference for you, let's go back to our virtual moon atlas for a moment. And that is the highlighted crater that we are viewing. We can zoom out a bit to give you just an idea of where overall we are looking at on the lunar surface right now. And as you can see, Tycho there is the one that's highlighted in red on the left-hand side of your screen. We're going to hit Clavius, and I think actually Clavius is the crater there just to the left. I always like that crater. It's a very busy area, got a lot of interesting features. I particularly like the 5 or so small craterlets in the main crater, plus all the other craterlets that are kind of on the crater wall. It just makes it a very interesting feature to scrutinize and look at telescopically. There we are. Let's see if we can get that centered more for everybody. Got the AC running, so hopefully that audio is not picking that up too much. If it is, I do apologize. Okay, so we are going to stay here just for a moment. We're going to bounce back to Jupiter, see what's going on there in just a moment. So enjoy the view here. We'll probably get another opportunity to get back to the moon before we wrap it up for the night. We've already been broadcasting just about an hour, I think, so far. So got a lot of things going on here. All right, so let's go ahead and see what we can find and see back to Jupiter. So say goodbye to the moon for a moment. We'll probably revisit. Let's check out Jupiter again. Oh, gotta love that. Right smack in the middle. Right smack in the middle. I love it when a plan comes together. All right. Let's bring up some. Yeah, okay. So let's do some tweaks here. So I can see the shadow. Hopefully you can too. So what am I talking about when I say the shadow? If you were just joining in, Jupiter has periodically, Jupiter has some interesting events. It always has something going on, basically. Whether it's these clouds that you can see here, these two main cloud bands, which are visible in very small to modest aperture, the north equatorial belt, south equatorial belt. You can see just about midway through the planet there on the belt that's to the left there, that spot that you can see, kind of an oval patch. That is actually what is called the Great Red Spot. It has been subdued as far as its color from discovery. It's more of an orange, probably light orange now, kind of cream color. And it's also gotten smaller since its initial discovery by Galileo. But it is still a telescopic feature that you can see usually with pretty modest instruments. Now the other feature here that we're looking at, and this might be more difficult for everyone to kind of see, but let me see if I can zoom in here. During moments of steady sky here, I want you to look. I wish there was a way that I could highlight this for you. There's a very dark dot, basically, that you're able to see just on the edge of the cloud belt to the right. Okay, take a moment, let that kind of Maybe the sky will get a little bit steadier, but I can see it. And what that is the shadow of Io. What's Io? Io is one of the 4 Galilean moons on Jupiter. And believe it or not, we're seeing live a shadow traverse the planet Jupiter. Let's go over to our Sky Safari program here, and you'll see this a little bit more in detail. So the orientation's a little bit different, obviously. This is more horizontal. Our view is more vertical. That's just the orientation of the scope and the camera. But let's zoom in here. Okay, here's the Great Red Spot. You can see that there. And there's Io. Actually, Io's actually the planet is somewhere right about there. I'm sorry, not the planet. The moon is somewhere about there in its physical location. But you can see the shadows lagging behind there, right over there, that black dot. And that, if we go back to our view, if we go back to our telescopic view, there we go. Let's bump this up a little bit here. If we go back to our telescopic view, I can see it. I can definitely see it in moments of steady seeing. I would love for you to leave comments on the video if you indeed see it as well. This is one of the reasons why Jupiter hooked me. This is the first object that I saw. It was back in 1985. Halley's Comet. And I have to admit, Halley's Comet was nothing very exciting. But when our teacher turned that scope to a bright star on the western horizon, and I looked through that eyepiece and I saw Jupiter, and as he was explaining to me exactly what I was seeing, saying, "Do you see those bands?" I said, "Yeah, I see the bands. Those are actually clouds, cloud belts on another planet." Pointed out the moons, the Galilean moons. Well, I was hooked. And hopefully maybe seeing something like this tonight, or whenever you happen to be catching this video, well, it's my hope that maybe you'll be hooked on astronomy. Maybe you'll be interested in finding out a little bit more. Maybe you'll look into joining a club, seeing some of the telescopes, stepping up to the eyepiece yourself. Maybe you'll find an event such as an outreach event like I used to do at a coffee shop. There's plenty of people that actually do that for the clubs too, from time to time. And you'll get the opportunity to look through these things. Jupiter's right out there. We got actually a great time. Actually, a fantastic time for planets, because we have Saturn that is getting higher and higher in the evening sky. That's going to be visible, actually probably might even be visible now. I have to look at my app. And of course, the big news is coming up, I think, either late July or maybe it's August. I should know this. But we have Mars reaching opposition, I believe, in July, and it's going to be one of the best times to view Mars since 2003. Very few opportunities to get to view Mars when it's this large or this close to Earth at opposition, so it's going to be a really good opportunity to look at the seeing right now. I'm looking at our live Jupiter feed here. Hopefully you're seeing it too. I can definitely make out the dot there for the Io shadow. Hopefully it's coming through the YouTube channel well enough for you to do so as well, because it's truly something very, very interesting to be able to see and say that you've seen it. Again, the Great Red Spot is on the lower left. And what we're talking about is in the upper right, on the other belt, there's actually some dark features probably in the belt itself there. They probably are festoons. There's darker features there. But I'm definitely making out what would be IO, and well, it's shadow at least, in the just above or right on the edge of that belt. Hopefully you're able to see it as well. I gotta get some video of this. This way we can process this later on and get a nice image out of this. Now, if those of you that maybe have joined that don't realize this, maybe because why is he talking about the great red spot? I don't see any color. No, this is a monochrome camera, or black and white, so you're not going to be able to see the colors with this particular camera that I am using tonight. Hopefully I will be getting a functional color camera. My actual color camera was acting a little weird, and I didn't want to go ahead and try broadcasting with that one. This is my very solid, almost always working older camera, but it is monochrome. Really shaken up though. You can see the atmosphere just shaking the view of Jupiter. But I think that's going to come out really, really well when I process that later. Okay, so again, well, I'm going to go back to our app. This is Sky Safari. This is usually an Android or iOS or Mac program, by the way. I think they actually still have it free. You might want to check it out. They have a starter version for free. So if you have those devices, certainly check that out. We're going to zoom out just a bit. You'll see the three other moons. From left to right, that's Ganymede, Europa, and Callisto. Io is on the planet right now, or in line of sight to the planet from us. So we're not really able to see the bright dot there. That's Io at the moment, but we are actually going to probably be able to see Io creep out from the disk of Jupiter. Here, I don't know actually what time that's going to happen, but it's certainly getting closer to the edge as we've been broadcasting. These, of course, make up the 4 Galilean moons. Jupiter has a bunch of other moons. You need a much larger telescope to be able to track those. I think it has upwards of 60 plus, if I'm not mistaken. Yeah, that's definitely Io shadow. Definitely seeing the Io shadow. Let's go back to that here. Keep clicking the wrong buttons. Sorry. There we go. So I sure hope that whatever compression or algorithm there that YouTube is using isn't going to crunch up this video and pixelate it too much for it to be a little bit blurrier, but I hope that you're going to be able to pick that out. Let's drop it down to actually 100%. This is the non-zoomed in view that I have, and we were actually viewing Jupiter about 175%. Let's recenter that up for you. Oops. Grab a drink here. Didn't want to put that on the microphone. So, by the way, astronomy doesn't have to be a nighttime endeavor either. In fact, there's a pretty special event going on Sunday. Yeah, this Sunday. It's called International Sunday. And this is a worldwide event where folks that enjoy observing the sun with obviously safe equipment in a variety of wavelengths. The sun is absolutely interesting as well. And International Sunday's going on. If you live in a large metropolitan area, or maybe even if you don't, it's worthwhile trying to see if there's any astronomy clubs or organizations that are going to be close to you that are going to be setting up telescopes. And again, this is completely safe solar telescopes. And just showing you the views absolutely free of charge. It's really fascinating to be able to see the sun in what we call white light. I think there's a couple of sunspots going on right now, but the real fun gets into when folks bringing out these specialized telescopes called hydrogen alpha, and you'll be able to see the sun in a very interesting wavelength there, and perhaps you'll be able to see what we call prominences on the edge of the sun itself. So check that out. If you're on Facebook, they definitely have a page, International Sunday. I encourage you to go there, like that page, find out any updated information on there. It's always cool just to be a part of that anyway, because you can always go ahead and get some interesting views after the fact, you know, see what other people had done, etc. This is an event that is a collaboration of a number of people and a number of organizations, clubs worldwide. Of course, one of the largest organizations there that really has been pinnacle at promoting it has been the Charlie Bates Solar Astronomy Project, which is a large nonprofit organization dedicated to solar astronomy outreach in particular. And another group of folks that just love sharing the sun and everything about the sun. If you're interested in learning about, you have to go ahead and join Solar Activity Facebook group. John O'Neill, Pamela, and oh geez, he's going to kill me if I can't remember his name. John O'Neill, Dorothy, and Randy, thank you. Randy Shavak and Pamela Shavak, they both have created those pages and run them. So plenty of good information there too. Lots of fun to watch to see what other people are posting up. My weather conditions here in Middle Tennessee are not looking good for this weekend at all. But in fact, of course, I'm saying that, but right now I'm able to obviously have some relatively clear skies. But for the daytime, that's really hard. We seem to have a weather pattern where it's almost like Florida, where it'll be clear in the morning, clouds will build up, you'll have a thunderstorm, it'll clear out for a little bit in the afternoon, then it seems to be building up again in the early evening hours through the night, etc. So it's just the way it is. But now, let's get back to Jupiter. Jupiter's looking good. A bit shaky. The Io, let's see, I would say Io right now is about mid-transit. It looks like it's just about at the halfway point, traversing the disk itself right now. Hopefully that is coming through the feed okay for you. Some settings here real quick. Oh, I think we have a little bit of high or thin clouds coming through because it seems like Jupiter's gotten a little bit dimmer here, and it's really starting to shake and shimmer. Let me check outside real quick. Yeah, I don't have a one of the to-do lists is to put together a little bit of an all sky camera so that I can whew, yeah, that definitely looks like clouds or something, so that I can go ahead and see. But let me go ahead and step outside and see what we got. Hold on. Well, actually, no. It doesn't look like it's clouds building up. Our seeing is just deteriorating as we are watching here. That's all that is. So let's actually go back to. We're going to go back to the moon for a while, and then we're going to bounce back to Io or Jupiter. Because one of the events that we should be able to see not too long from now, maybe Io actually coming out from in front of the disk of Jupiter itself. So off to the moon we go. As you can tell, we're not that far away. Really becomes evident now of just how much atmospheric shaking's going on with when we are looking here at the moon. There we go. Shaking. Go to a different area here. A couple of my little favorite go-to guys, Messier A and Messier B. Those are the two little craters that you're seeing on the left that almost looks like they have headlights going. That's actually a ejecta blanket from these two craters. The object that created those craters no doubt had a very shallow angle when it impacted the moon to create that very elongated straight line ejecta there that you're seeing from those two craters. Now, of course, you got the big one there. I believe that's called Proculus. Let's go back to the Lunar Atlas here just to make sure that I am correct. It's been a little while for my lunar knowledge here to get some practice. And yes. So I think it's just called, no, it's Proculus. Okay. Proclus. All right, so you can see the very, very wide ejecta blanket, but very bright from that other crater there on the right hand side. Sorry, I'm going to try to get this centered up better. There we go. Ooh, seeing is just getting really bad here. Seeing if I can tweak focus at all, but it's probably not going to make much of a difference. You can see how it's boiling there almost. So you can see the crater in the right, how it's got that fan-shaped ejecta blanket. That's Proclus. And the two smaller ones way over to the left there almost look like they got headlights on. Those are Messier, A and D. Wow, the seeing is deteriorating so rapidly. It's actually kind of amazing that we've seen this much change in just such a short period of time. There, I focused a little bit, and that might help a little bit here with the clarity of the view. But that's more atmospheric than anything else. And we just can't fix that. But We'll visit some of our old friends here. I believe that is Copernicus. And just to give you an idea of whereabouts we are looking in the moon, let's go ahead and switch over to Virtual Moon Atlas. And as you can see, Copernicus crater there is the one that's highlighted in red just about at the top. So that is just about where we are if you were to go outside and look up on the moon itself. Funny, I just figured out how to shrink the window. Maybe that won't do it. me go back here, see what we got going on. Nope, it's got a little bit longer to go for Jupiter. So let's stay on our moon here. We'll go along here on the Terminator. Oh, there's Rupus recta, I believe it is. The straight wall, we call that. For obvious reasons. I don't know if you, hopefully that's coming through pretty good for you. That line there is not any anomaly from the camera or anything like a string on the scope itself. That is a feature on the moon. And we are able to see that pretty clearly here. Camera did not freeze up here. Oh boy. Okay. Yeah. We've got a little bit of a technical glitch. So let's go back and have you look at this for the time being until I can figure what's going on with that camera. Okay, I think we've got that little hiccup resolved. Let's go back to our live image here, maybe. And let's see what we got. All right, so as you can see, so what I was talking about before was that line that you're seeing in the left-hand portion of our image, upper left a little bit, that actually is not an anomaly of the camera. It's not a string. It's not a lint. It is literally a feature that is on the moon, and it is called the straight wall. I believe the technical name is Rupus recta. But let me go to my trusted virtual moon atlas just to make sure. Yes, that is the straight wall. So what we'll do is we'll go back to our app here. It actually comes out much better on the live view than it does on our atlas, but let's go over to the atlas to show you what I mean here. So there's our atlas. So there's our three main craters. Ptolemais, Alphonsus, and Arzachel. Phoebit directly below the Rupus recta, or the straight wall. And we'll go back to our live image. is having another hiccup. That is odd. Okay, so what we will do is, give me one moment here. Let's go back to our Sky Safari app. We're going to get back to Io here and Jupiter because it looks like we might be able to start to see Io coming out in the field of view if we can do that successfully. Let's see what we got. All right, so let's go back to Jupiter right now and see if we can get Io teased out here as it comes out from in front of the planet itself. Increase the gamma. Yep, I can actually already see it myself here. So now we're actually going to be seeing the planet or the moon. I'm gonna have to reset this camera again here. Be right back for technical difficulties. Hold on. Okay. Hopefully we're back. Hopefully we're back for at least long enough for you to see this. Because this is pretty cool. So here is Jupiter. And I know that you can start to see that little pimple there on the bottom of Jupiter. That is Io itself. That is the moon that has been essentially invisible to us as it's crossed the front of the planet, and now as it's getting out from the edge there, it is becoming visible to us finally. Be interesting to know why I seem to be having the camera issues I am. Nothing really has changed, but at least the image is up on the screen here. See if I can increase it a little bit for you. It's not great, but see the little bump there on Jupiter to the lower portion? That is Io. That is the moon here. We'll go back to what we're comparing that to on our Sky Safari program. Let's see if we can get that visible. There we go. So you can kind of see that's what we're seeing basically. Let me drop that down to 15 maybe. We're still having camera problems. Interesting, interesting, interesting. Well, you know, that's when you know this is live. When you can actually experience some of the problems that amateur astronomers have with their equipment, especially me. Seems like from time to time. Okay. Well, I think that's probably going to be a wrap because I've done just about all I could think of doing to get this camera stable. Don't know why it's acting the way it's acting. Program uses the program. Okay. Here's what we're going to do. That's what happened. Okay, now I know why what happened probably. At least for that brief moment, maybe? Maybe not. No, I'm not that lucky. Thought maybe it was because we had a couple of instances of the program running and that's a no-no. We'll zoom out a bit here, give you the whole picture now. If you were able to go outside with a pair of binoculars and look at Jupiter, now you're able to see all 4 of the Galilean moons. You'll be able to tease out Io right on the edge of the disk there for Jupiter. Just on the edge. All right, gang. Well, I think we are going to have to call it a night. I hate to end the night on a little bit of a technical glitch, but it looks like that. I don't really have much of a choice right now. I'm not sure what's going on with the camera. And, well, at least tonight we've got to see some cool craters, some cool features on the moon, and hopefully you were also able to see some of the awesome phenomenon that happens on Jupiter. Great red spot, as well as an Io transit and an Io shadow transit. So make sure, I'd love to hear from you, your comments here on the video yourself, if you have actually seen, if you were able to see it, etc. Love to know if that was the first time you saw something like that on Jupiter. All that cool stuff. Would love to hear from you. Don't forget, please subscribe. And we also do a podcast here. You can find the podcast if you want to listen to it, rather than, of course, listen through the YouTube channel. It automatically posts to YouTube. But it's hosted on a site called Spreaker.com. So if you go to Spreaker.com, just look for @the Eyepiece there. You can also listen to the podcast directly from my blog. Simply go to @theeyepiece.org, and you will see at the top, one of the options there is listen live to the show. You'll have the ability to go ahead and listen to past episodes, etc. there. So for tonight, that's going to be a wrap. Sure hope to see you next time here so we can check out some other cool things from our universe right here at the Eyepiece. Thanks everyone for watching and hanging out with me. Really appreciate it.